Okay, the last bit that we did not cover together is metallic bonding. So what is metallic bonding? It's a lattice of positive ions in a sea of delocalized electrons. So what happens is you have metal atoms and they all lose electrons, the outermost electrons or valence electrons. And these electrons that have been lost, they are the ones that form the delocalized electrons, like the red dots here. Okay, and then the cations then retain a positive value or charge. These cations, they form a lattice structure, and in between them it's like the electrons are lubricating the spaces in between. Okay, so this is a giant structure, so you can make inferences about melting and boiling points. This type of bonding only happens with metals. That's why it's called metallic bonding. The strength of metallic bonds depends on a few things. So how many electrons, delocalized electrons we have. So for instance, if you have a metal in group 3 versus group 2 versus group 1, 3 or 13, then the valence electrons will be 3, 2, and 1. You can imagine that the one that has 3 valence electrons and loses 3 valence electrons will have more delocalized electrons. So it's going to be a stronger metallic bond. Okay, the other thing is the charge that's left over after it loses electrons. So if you lose 3, you get a 3 plus charge. If you lose 2, you get 2 plus charge. And if you lose 1, it's a 1 plus charge. So again, the higher the charge, the stronger the attraction or the metallic bond. One last thing is radius. Okay, if the radius is small, then it's a tighter, or the electrons, the delocalized electrons are more attracted to the nucleus. Okay, I don't know whether you guys remember Coulomb's law, where force was directly proportional to charge and force was inversely proportional to radius. Okay, so we saw this when we were looking at ionic lattice. It's similar even here. We have already seen properties of metals, and here's a nice table that summarizes them. Conductivity is very important. Thermal conductivity, not so important in chemistry. I've never seen a question in IB test about this, but if the question is asking what are some of the properties of metals, definitely use good thermal conductivity. Okay, we've seen that they are malleable and they can be drawn into wires. They have high melting because they're a giant structure. And I don't know whether you remember when we were playing around with sodium, lithium, and potassium. Like when you cut them, they were very, very, very shiny. Okay, so a lot of metals are very reactive, and because they are reactive, even though they could be useful, they are not, because they would then react. So alloys are made in order to reduce the reactivity of metals and make them more useful. What alloys are is basically enhanced metal solutions. Metal solution. I know a solution, when you think of solution, you think of something in liquid form, but in this case, it's like mixing of two solids. Okay. They usually contain more than one metal. They can contain other things except for metals, but they usually contain more than one metal. They are more chemically stable and stronger. Okay. And they are more resistant to corrosion. So they react with oxygen in the air much less than pure metals. And so that makes them very useful. Also, they are much, much, much stronger. If you can remember how some of our pure metals were almost paste-like. When we're looking, lithium was the most toughest, and then potassium was almost like a paste. Okay, so you can imagine as you go down the group how the rest of them are. So alloys, they mix more than one metal and they become more stable. Okay,